All right, good morning. Welcome back to Intro to Statistics. Today we are going to start talking about Chapter 4. So I'm going to give you a little preliminary idea about what this is about, and then we will talk about some homework problems. So let me go ahead and share my screen. Okay, I could get my ugly mug off of this thing, and we will show you what's going on here. Okay, the first thing that we're going to talk about is this formula. You are not supposed to memorize this formula. Okay, so we will ask you to calculate correlation coefficient here. Okay, so the idea is your correlation coefficient is going to be between -1 and +1. Okay, so a couple of things. That's one of the things we have to say. Let me go ahead and grab this guy. Okay, so R, that's correlation coefficient. Okay, this is for a sample correlation coefficient. Okay, we use a rho. I know it looks like a P, but that's a rho. Okay, for a population correlation coefficient. Your book doesn't really go into that. So if you see this row, people are calling it correlation coefficient. Just understand that they are using a population correlation coefficient. And again, Greek R correlation coefficient, same thing as Greek S for sigma for population standard deviation. And we use a Latin R correlation coefficient and a Latin S for standard deviation. Okay, but that's the formula that we have here for it, and it's on screen right now. Do not memorize this formula. All right, you will have access to a calculator. You already use the calculator. Okay, so one of the things we have is R has to be between -1 and +1. The closer it is to the extreme, -1 and +1. So if R is equal to 1, we're going to have like a dot, 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 dot. Okay. It doesn't have to be that kind of a slope. It could be any, it doesn't say anything about the slope. It just says like the line up. So don't think correlation has anything to do with the value of the slope. That's the m part, the y equals mx plus b. We just worry about how much do they line up on, how much do they align with this line here. Okay, if we have correlation is equal to -1, then again, we're going to have dot, 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 dot. Okay, so it's going to be a perfect line. Okay, so correlation equals 0 means that there is no line, there is no linear relationship between the two variables. So there's just, a dots. And you'll see as you get into the homework, okay, this is not a Rorschach test. We're not trying to do an ink blot test and like have you look at this and say, what's the relationship? And then you look at it and say, I see a butterfly. Like, no, you don't. There's a blob of dots there. There's no relationship. Okay, if they want you to see a pattern at this level, they generally type in pretty uh, a pretty obvious pattern. Okay, so don't try to find patterns where we don't have patterns, don't exist. Okay, so just be careful about that. The kind of thing you're going to see on a regular basis. Like, that's not a very good line. I'm like, no, it isn't. So this is going to be an R is like a 0.7 kind of a thing. I mean, it's kind of a line up on a line-ish, but not exactly. Okay. Notice about the slope though. Um, when R is positive, we tend to have a positive slope. When I had R was negative, we had a negative slope. Okay, that's the only thing that has to do with the slopes. Okay. R is 0 is there is no linear relationship. It doesn't mean there isn't a relationship. It means there's no linear relationship. For if you, I've got a couple of students I know that have taken trigonometry. You end up with like a scatter plot that looks something like this. Like, is there a pattern? Yes, there is. Is it a linear pattern? No, it is not. So in this case, my correlation is 0, but I wouldn't say there's no relationship between the two variables. There's clearly a pattern here. Okay, it's just not a linear pattern. So be very careful about when you have correlation versus, and you're talking about different kinds of data. One of the questions we like to ask is like, is there a correlation between blonde hair and blue eyes? Like, well, there's a relationship between blonde hair and blue eyes, but what number did you give blue eyes? What number did you give blonde hair? Can I rank them? Can I use this formula to actually calculate a correlation coefficient with blonde hair? What's X? What's the X value of the average for the blue eyes? What's the standard deviation for the blonde hair? I have no idea. So it has to be numerical data. Okay, people use this word correlation very casually, so we're not going to do that in statistics. But at the same time, you have to be aware of the fact that people use that very casually. And the other big point I want to make before we run into the homework, and this is correlation is not causation. Where one variable has an impact or has a relationship with the other variable. When one variable increases, the other variable increases. So, we would have a positive correlation. Let's see here. Drownings in pools and ice cream sales happen to be correlated. Number of drownings and number of drownings in pools happen to be correlated. If we could only get people to stop eating ice cream, we could save thousands of people from drowning. I don't think that's really the point they're trying to make there. So you have to look for what else could be causing ice cream sales to increase and what could be causing people to spend more time at pools. Oh, summer would do that. So just because two variables are related does not mean one causes the other. Okay, one very political one that people like to do is well, video games cause violence. Well, are people who are prone to violence drawn to violent video games, or do people, who like violent video games tend to be violent? I mean, there might be a relationship there, but you can't say one is causing the other, because as soon as you look at a country that say isn't the United States, that relationship kind of goes out the window. So even if you do look at the United States, that relationship kind of goes out the window. So even though you might think oh, these two things should be related and one causes the other, that's not necessarily going to be the case. Okay, so this is, let's see if I can remember how this works exactly. So yeah, just because two variables might be related, you don't know that variable one causes variable two, or variable two causes variable one, or could there be an influential factor? Is there a factor that's not accounted for both of these? And then sometimes there's no relationship whatsoever. It just happens to be people will, with computers, we will look at dozens upon dozens of different variables to see if they're related. Okay, no, that's not how you spell that. Something called spurious correlation. All right, and there's very good numerical evidence to show that the number of people who die by being tangled in their bed sheets is correlated with the per capita amount of cheese that we eat. So again, if we could only stop people from eating cheese, dozens of people would be saved by not being tangled in their bed sheets and dying that way. But chances are there isn't anything going. I mean, you might say alcohol might be a factor. Okay, that's fair. But there isn't any kind of relationship between the two variables. It's just we just checked for dozens upon dozens of variables. We happened to fish one up that did that, and then say, oh, look at that. Okay, they happen to have a relationship. It doesn't mean anything. Okay, so be really careful when you're looking at correlation, causation. The other thing, again, just to remind us, correlation is a measure of the linear relationship. Okay, so if we end up with some kind of a, scatter plot like this, again, this is not going to be a linear relationship. There's a bend in it. So the correlation would probably be very, very low here. Okay, but there's clearly a relationship between the two variables because you can see a pattern in the scatter plot. Okay, it's just not a linear relationship. So you have to be careful about that. Okay, so when you're seeing a scatter plot, okay, as even if somebody's well, I only had one statistics class and I've got all these statisticians giving me a presentation, and you see a scatter plot like this, and their PowerPoint slide has correlation equals, and they'll come up with a number. I don't know what this number would be, but maybe it's 0.6 or something, and they'll say, look, it's correlated. The question you can ask is like, well, what led you to believe that there's a linear relationship between these two variables? I mean, yes, you do have a correlation, but I'm looking at the scatter plot, and I don't see a linear relationship here. So why would you think that that's the case? So, any analysis you've done after the fact is pretty much garbage because you decided there's a linear relationship, and you don't have that. For the people who are going to go off in engineering, you're going to have scatter plots that look like this occasionally. You don't want to pick a linear relationship. You want to pick some kind of an x squared. Okay, and that's the kind of model you want to start with. So since linear relationship is the easiest one, and most humans do that, we usually start with a linear relationship and say that's the assumption we're going to make. But understand, like, the first step that we've made here is looking at the scatter plot and saying, oh, I think there's a linear relationship. You should question that. Okay. So try to be careful when you're doing correlation, you're looking at these scatter plots. Make sure you're looking at the shapes. Just because they have a number attached to it does not mean that, like, the calculation is probably correct. I'm not going to argue with you on the calculation. But when you look at this and say, oh, I think, you know, like, what led you to believe that there's a linear relationship here? It looks like there's a bend of A. So even though you've come up with a nice fancy number, like, that's great. I don't agree with your initial assumption that there's a linear relationship. So just be really careful about that. Okay, and again, just to reiterate, correlation, not causation. One of the studies that I had read a long time ago was talking about wine consumption and longevity. The people who have a glass of wine for dinner tend to live longer. Like, does it mean that one's causing the other? No, it does not mean that. What's my risk of having a glass of wine with dinner? Well, if I'm an alcoholic, that's a pretty big risk. You probably don't want to do that. But for me, I'm, north of 200 pounds. If I have a glass of wine with my dinner, I'm not prone to drink more than that. And I'm not taking any drugs that are going to have a bad interaction with alcohol. Uh, Chances are having a glass of wine for dinner is not going to be a detriment to me. So it's okay for me to look at this and say, I think it's okay that I have a glass of wine with my dinner because the evidence kind of suggests that there's going to be a health benefit here. I'll live longer. And then the downside is I've got to buy wine once a week to have enough wine to go with dinner for a week. So we're not talking about a huge cost or huge detriment for doing this. Okay, so that's one of the other things you have to weigh as well. Is like, if they're going to come up and say, well, doing this highly risky thing is going to be increase your health benefits. Like, I don't know if I would jump in it. Okay, it's just not something that it's not worth the risk of the downside. Just because there's a study doesn't mean necessarily that that's going to be true. Usually, scientific studies, you have to do 2, 3 studies, and they have to be done kind of carefully. I mean, most of the people I'm talking to are of a generation where when you were born, cigarettes did not cause cancer because we hadn't studied that to the appropriate level yet. Okay, we have now cigarettes cause cancer. They have that on the package now. But when I was born, they did not. Even though everybody knew that people get emphysema, people get lung cancer. That's not the only way you can get lung cancer, but cigarettes is not good for you. But they couldn't put that warning label on the package because they didn't prove it. And it's not an ethical thing to do. I can't go to everybody in the class and say, okay, I'm going to give you, 2 cigarettes a day. You're going to smoke 4 cigarettes a day. We're going to have some people smoke 2 packs a day. We're just going to go up the class and we're just going to have that done. And then when the experiment is over, okay, we call it in science when you do that to mice. Okay, you give them different substances to eat or whatever. We sacrifice them. Okay, you don't kill them. We sacrifice them. So I could sacrifice you and then count the tumors up in your lungs and then try to relate how many cigarettes you had and then try to relate that to the tumors in your lungs. That's not really an ethical experiment. So we had to come up with other ways to do this experiment. It was robotics, and we did it with animals, which is sad, but that's what we do. Okay, rather than sacrifice humans, we sacrifice mice. Um, it was sad for the mice, but that's the way it goes. Uh, but it was not an ethical experiment to do. So you had to perform this experiment to actually do it. That's what we have to do. Okay, so even though now we could say cigarettes cause cancer, it took a long time. They were just simply correlated together. I still wouldn't have recommended, even when I was born, people would recommend, like, don't smoke cigarettes. It's not good for you. But you couldn't put it on the package because they didn't prove it. So just because we have an idea that two things might be related, it's not proven yet. It doesn't mean it's wrong. It just means that we haven't gone through all of the ethical testing and all of the all we haven't gone through the entire process to say that it's so. So if it's just simply correlated, you have to take that with a little bit of salt. You have to take it with a little bit of skepticism. Okay, so just be careful about that. That's the biggest. And you'll turn on the news and say, "Well, we have an increase of this because of that." Like, no, they're correlated. That you don't have a causal relationship. So I just wanted to warn you about that. I'll stop talking. We'll go through and do some homework for a moment. But again, all of the formulas that we have here that are in the book like this is the one point in the in the book where I'm going to say, you know what? Do not memorize these formulas. Okay, don't memorize. Know how to do it on a calculator, but you are not responsible to memorize this formula. You are responsible to know that correlation is a measure of the linear relationship between two variables, but you are not to be memorizing these formulas. Okay, so I'll leave you with that, and I will see you in the next video when we go do some homework. Thanks.